In this video, I'll explain how to solve a system of linear equations using Cramer's rule. In our case, we have two linear equations. This is equation 1, 3x plus 7y is equals to 5. And this is the second equation, 2y equals to 3 minus 5x. And we have to use Cramer's rule. Remember, there are other methods that you can use to solve systems of linear equations, but in this case, the specification is that we should use Cramer's rule. So this is Cramer's rule in brief here. X is equals to delta x over delta, and y is equals to delta y over delta, and z is equals to delta z over delta. It does not matter how many variables we have. In our case, we just have two variables, x and y, so we don't need this. We don't need z. However, even if we have 4, 5, no matter the number of variables, all we have to do is to get this delta x over delta, delta y over delta, delta z over delta. Each variable should be represented. Now, in using Cramer's rule, all you have to do here is to get these deltas, so the delta and the delta x, this delta y, and even delta z if we have more than two variables. That's all we need to do. So I will be explaining what is delta and how you find delta, what is delta x and how you find delta x, what is delta y and how you find delta y. That's all I will be explaining. I also want you to know that the method I'm using for two linear equations is the same method that you use for 3 or 4 or 5 linear equations. As long as you're using Cramer's rule, it is the same method. Just that with two linear equations, it's quite simpler, but it is the same method. Now, let's go to the first step. What you have to do first, and this is a very important step. So first step, whenever you're using Cramer's rule, your first step is to rewrite or rearrange your equations. So see how I'm going to rearrange my equations. I'm going to write the first equation as 3x plus 7y equals to 5. This is my equation 1. My second equation, I'll write it as 5x plus 2y equals to 3. The aim of this step is to ensure that you have columns with the same variable. In other words, like terms are in the same column. So if you look at this first column, I have x's, second column I have y's, and the third column just got constants. That should be your first step. Make sure you write it neatly in a very organized manner and have like terms in the same column. It's a very important step. That's our step number 1. Now, we now have to write these deltas that I referred to as deltas. That's our step number 2. We write them and we evaluate them. Pay attention. I'm going to start with delta alone. Let me use a different pen. Delta is the determinant of coefficients. Delta is the determinant of coefficients. What are my coefficients? 3, 7, 5, and 2. These are my coefficients. So delta is simply a determinant of those coefficients. So I'm going to use straight lines here to indicate that it's a determinant. So this is 3, 5, 7, and 2. I use a straight line. This is our delta. And since the 2 by 2 determinant, you just use the method of evaluating a 2 by 2 determinant. If you have forgotten how to do it, check one of the videos that I'm going to attach in the description and use that to revise how you evaluate the determinant, a 2 by 2 determinant. So in this case, I'm just going to give you a brief explanation of how you do it. When you're evaluating a determinant, you take the product of the major diagonal, subtract the product of the minor diagonal. So this here is your major diagonal, this here is your minor diagonal. So the determinant here is 3 by 2. This is the product of the major diagonal minus 5 by 7, the product of the minor diagonal. The answer there is minus 29. That's the answer. It's minus 29. Now that we have our delta, we can now move on to find delta x and delta y. To find delta x, we start with having delta. I want to highlight a few things here. If you look at this column, the first column, these are the coefficients of x, and the second column contains the coefficients of y. Now, this is how you deduce your delta your delta. So this is delta x. Okay, in delta x, we simply replace the coefficients of x with the constants. In other words, the numbers that were to the right of our equal sign, which was 5 and 3. So here where we use in this first column now is going to have 5 and 3. The second column is still 7 and 2. This is our delta x. We started with delta. We went to the column that had x values in our delta determinant. That column, we replaced it with the constants, which were numbers to the right of our equal sign. See, this actually tells you the importance of rearranging the equations so that you don't mix up coefficients of x, coefficients of y, and the constants. It's very important that you arrange your equations neatly in nice and neat columns and rows. Now, delta x is a determinant, which is the determinant of a 2 by 2 matrix. We use the method that we use also in evaluating delta, which means the products of the major diagonal, this one is the major diagonal, subtract the product of the minor diagonal, this is the minor diagonal. So in this case, it's 5 by 2 minus 3 by 7. This is 10 minus 21, so the answer is minus 11. So minus 11 is our delta x. Please note that sometimes the question may just say find x. You don't have to find y. In that case, you just find your delta x and your delta. You stop there. You don't have to find delta y. But in our case, we have to find x and y. So we should find delta, delta x, and delta y. So let me go to delta y. Let me use a different pen for delta y. So this is delta y. Delta y, we start from delta. We go to the column that contains the coefficients of y. We replace that column with our constants. So here, the first column is still 3, 5. The coefficients of x remain, but 7 and 2 are going to be replaced by 5 and 3. So this is 5, this is 3. Now, this is a 2 by 2 determinant. Product of major diagonal, subtract product of minor diagonal. So we have 3 by 3 minus 5 by 5. The common mistake here is to mix or to confuse the major diagonal and the minor diagonal. Please don't confuse that. So we have 9 minus 25. The answer is minus 16. So our answer here is minus 16. Now that we have delta, delta x, and delta y, we can now apply our Cramer's rule to get our x and our y. So let me use a different pen. Now, delta x is equals to delta x over delta, which in our case is delta x is minus 11 divided by delta, which we got is minus 29. The answer is simply 11 over 29. That's our x, 11 over 29. Sometimes they may want us to express our answer as a decimal. You can do that. That's our x. Then our y is delta y over delta. Our delta y is minus 16. Our delta is minus 29. So our y is 16 over 29. So we have solved for x and y using Cramer's rule. Where is the challenge? The challenge is in getting these delta x and delta, delta y and delta. And if we have 3 equations, it means we're going to have a 3 by 3 determinant. So evaluating a 3 by 3 determinant is a bit different from how you evaluate a 2 by 2 determinant. However, the approach still remains the same. You simply have to find delta, delta x, delta y, delta z, or even delta q if you have another variable called q. So you find them all. To find your x, you simply divide delta x by delta. To find your y, delta y divided by delta. To find your z, delta z divided by delta. The skills that you should have when coming to this, to applying Cramer's rule, you should know how to evaluate determinants. 2 by 2 determinants, 3 by 3 determinants, or maybe 4 by 4 determinants. As long as you know how to evaluate determinants, you can do Cramer's rule without any problem. And also take note of how you get your delta x and your delta y. Let me just recap that. If you're looking for delta x, you start with delta. Remember, this delta here is a determinant of coefficients. Each column is having this coefficients of the same variable. So in this case, column 1, which is 3 and 5, these are the coefficients of x. Column 2, 7 and 2, these are the coefficients of y. If we're looking for delta x, we go to our delta, we replace the column of x coefficients, we replace that with the constants, which were the numbers to the right of our equal sign. In our case, it was 5 and 3. That's why we have 5 and 3 here, replacing 3 and 5. It's just a coincidence that it's still the same numbers, 5 and 3, but just take note of what they are representing. This 5 and the 3 are simply representing the numbers that are our constants in our original equations. That's delta x. In delta y, you go to the column that had y coefficients in our delta, then you replace them with the constants, in our case with 5 and 3. That's all. Once you know how to write your delta x, and your delta y, the next challenge is to evaluate the determinants. If it's a 2 by 2 determinant, I have shown you how you do it. This is the method. If it's a 3 by 3 determinant, there is a different method. I'll attach the link to some of the videos where I was explaining how to evaluate a determinant for a 2 by 2 matrix and a 3 by 3 matrix. Otherwise, this is Chromos Rule. If you have any questions, let me know in the comments below. I will respond. Thank you.